Hello and welcome to Neat Prep Go. So the earlier video we did a bit of injuries, but then we also did sports medicine, whereas we have to do physiology. That was the old edition, so it's good that we did that. Okay, more or less the same, but this physiological factors is very important. So we'll just do this and then we'll continue with bone injuries. Okay, so in the same chapter only, they have just changed the name. Okay, this year's edition. So physiological factors determining strength. What are the physiological factors which determine strength? Okay, first is the size of the muscle. So the bigger the size of the muscle, the more will be the strength. The strength of the muscle largely depends upon the size of the muscle. It is well known that bigger and larger muscles will have more force. Force produced by same size of muscle in males and females is approximately same, but in males it is found to be stronger because they have bigger and larger muscles in comparison to females. Okay, with the help of different methods of strength training such as weight training, size of muscle can be increased and thereby the strength can be improved. So basically, the first factor, physiological factor which determines strength, is size of the muscle. Then second is body weight. It is also a well-known fact that individuals who are heavier are generally more stronger because there's a positive correlation between weight and strength. Therefore, the body weight, when the body weight is high, then the individuals are stronger. So the second factor that determines strength is body weight. Now the third factor is muscle composition. Each muscle consists of two types of muscle fibers. We have learned about this: white fibers, red fibers. That is basically collagen, and we used to learn before. Okay, so now anyways, here it is written fast twitch fibers and slow twitch fibers. Fast twitch fibers are capable to contract faster and therefore they can produce more force. The slow twitch fibers are not capable of contracting faster, although they are capable of contracting for a longer duration. The muscles which have more percentage of fast twitch fibers, they will produce more strength, and that is genetically determined. You cannot increase it. Only to a certain level you can, but you cannot actually, because it's genetically determined muscle composition. And then the last factor which determines strength is intensity of nerve impulse. So we know that muscle is made up of a lot of motor units. The total force of muscle depends on the number of contracting motor units. So whenever a nerve impulse from the central nervous system is there, the stronger the nerve impulse, the more contraction will happen of that motor unit, and therefore the muscle will also contract that much strongly. Therefore the strength is also positively correlated to the intensity of nerve impulse. The more the intensity of nerve impulse, the higher will be the strength of the muscle. So basically, what are the four physiological factors which determine strength? First is your size of the muscle. Then second is your body weight. Third is your muscle composition: white fibers, red fibers, more amount of fast twitch fibers, that is white fibers. Slow twitch fibers, red fibers should be less, genetically determined. And then the last one, that is what is the last one? Size, intensity of nerve impulse. Okay, more the intensity of nerve impulse, the higher will be the contraction, and therefore more the muscle power, now strength. Now physiological factors determining speed. Mobility of nervous system. Our muscles contract and relax at maximum possible speed as seen in sprinting events. The rapid contraction and relaxation of muscles is made possible by rapid excitation and inhibition of the concerned motor centers. This is called as the mobility of nervous system. Therefore, the more the mobility of nervous system, the more will be. So basically, what is mobility of nervous system? We know that our muscles contract and relax at maximum possible speeds. So our neurons also, that is this rapid contraction relaxation of muscles is because of excitation and inhibition of the motor centers. Okay, not neurons. You don't write neurons, you write the motor centers. So this is called the mobility of nervous system. Nervous system can maintain the rapid excitation inhibition only for a few seconds, after which our speed will decrease because it spreads to the neighboring centers, the tension in the entire body. This results in decrease in speed. We can increase the mobility of nervous system only to a certain extent. It is determined greatly by the genetic factors. Okay, so first is for speed, the physiological factor which determines speed. First is your mobility of nervous system. Okay, the greater the mobility of nervous system, that is the more longer the motor centers can stay excited, the higher will be your speed. Then comes muscle composition. Again, more the fast twitch fibers, higher will be the contraction. Okay, and the more will be the speed. With lower muscle with greater percentage fast contract more with more speed in comparison to muscles with low. Yeah, so muscle composition is genetically determined, therefore different athletes have different performance and different parts of the body, the fast twitch fibers wherever maximum there. Okay, now explosive strength. For every quick and explosive movement, explosive strength is indispensable. For example, quick punch in the boxing cannot be delivered if the boxer lacks explosive strength. Explosive strength depends on muscle composition, size, as well as coordination. It also depends on metabolic process. Muscle composition can be improved through training. Except for muscle composition, rest all can be improved. Okay, which will improve the speed to a certain level, only to a limited extent. um, uh, the relative proportion of fast twitch and slow twitch fiber determine to a large extent what is the how fast the muscle can contract. The proportion of fibers is genetically determined. Okay, endurance athletes have more percentage of slow twitch. So those athletes which have more fast twitch fibers, they go in short races. Okay, that is more for where speed and agility is higher. Which the athletes which have more slow twitch fibers, they basically go for endurance. Okay, because they can run for a longer time. Okay, so then fourth one is flexibility. That is the fourth factor, which the physiological factor which determines speed is flexibility. That is flexibility allows maximum range of movement without much internal resistance, enables complete utilization of explosive strength. Okay, flexibility enables complete utilization of explosive strength. Fifth one is biochemical reserve and metabolic power. For maximum speed performance, muscles require more amount of energy. Okay, we know that many athletes take supplements. Why? Because of this reason. The muscle require more amount of energy at very high rate of consumption. For this purpose, phosphagen, adenosine triphosphate, and creatine phosphate stores in muscle should be enough. Energy supply also depends on certain enzymes which increase the metabolic power. Therefore, it can be said that biochemical reserve and metabolic power determine the speed. Physiological factors which focus on endurance. Okay, so first is aerobic capacity. What is aerobic capacity? The ability of an organism to maintain adequate supply of oxygen by working muscles is known as aerobic capacity. Okay, so basically by the working muscles, if so like when you run, continuous oxygen supply is has to be provided to your muscles. Okay, so for an organism wherein when an organism maintains a supply of oxygen to the working muscles, then for energy liberation, for an endurance performance, then that is called as the aerobic capacity. Aerobic capacity depends on what features. First is oxygen intake. That is the amount of oxygen our lungs takes up from the atmosphere. Maximum amount of VO2, then maximum results. Okay, because and then oxygen intake also depends on our lung size, its capacity, number of active alveoli, strength of the respiratory muscle. Okay, all these things. Then oxygen transport. Now the oxygen has been taken up by your lungs. Okay, now the oxygen will transport to the blood which is absorbed from the lungs to the circulatory system and carry it to the working muscle. The amount of oxygen taken into the blood from lungs has to be transported to working muscles. Okay, so the amount of oxygen absorbed into the blood depends on the speed of the blood flow through the lungs and on the blood hemoglobin. The concentration of blood hemoglobin, which is about 14 to 15% in sports person, cannot be enhanced by training. Okay, oxygen uptake is the amount of oxygen which gets absorbed and consumed by the working muscles. Then the speed of amount of oxygen consumption also depends on number, size, and metabolic capacity. Energy reserves. Aerobic capacity also depends upon availability of fuel to the muscles from which energy for the activity is derived. Therefore, the aerobic capacity depends upon the muscle glycogen and sugar level in the blood. If the muscle glycogen levels fall below a certain level, then fatigue occurs. Muscle glycogen and liver glycogen reserves are important. In extraordinary long duration, fats can be used as an energy source. Second for endurance is lactic acid tolerance. The ability to tolerate higher concentration of lactic acid is a significant factor for determining anaerobic capacity. The lactic acid tolerance is important for activities that last for about 40 seconds or more. Okay, movement economy. The economical movements are significant for endurance performance. A runner who can run at a given pace with less energy expenditure can continue with same speed for longer duration. Okay, muscle composition. Again, they are better suited for endurance activities. Again, over here it's reverse. The slow twitch fibers are best for aerobic or endurance activities. Okay, because they produce small levels of force for long periods of times. Okay, so they have 90% of slow twitch fiber, the marathon runners. Now muscle strength, that is for flexibility. Physiological factors determining flexibility. First is muscle strength. The muscle should have minimum level of strength to make the movement possible, especially against gravity or external force. Okay, strength should be minimum for flexibility. Okay, and the legs or knees cannot be lifted to the required height or angle if the related muscle are weak. Wait, what is written? The muscles should have a minimum level of strength to make the movement possible, especially against gravity. Maximum. This is a spelling mistake. This should be maximum. Okay. In fact, weak muscles become a limiting factor for achieving higher range. Okay, so maximum muscle strength should be maximum. Joint structure. There are various types of joints in human body. Some of the joints are intrinsically have greater range of motion than others. Okay, age and gender. Flexibility decreases with the advancement of age. However, human body is trainable. Flexibility can be enhanced with the help of training. Stretchability of muscle. Stretchability of muscle is also a factor in limiting the range of movement. For making any movement at a joint, muscle must also contract and execute in the same manner. If muscles are not regularly stretched, they tend to get shorter and restrict the range of movements possible at a joint. Internal environment. Internal environment of the athlete influences the flexibility. For example, 10 minutes in a warm bath increases body temperature and flexibility, whereas 10 minutes staying outside in 10 degrees Celsius reduces body temperature and flexibility. Previous injuries. Injuries to connective tissues and muscles can lead to thickening or fibrosing on the affected area. Fibrous tissues are less elastic and can lead to limb shortening and ultimately lead to reduced flexibility. Alright, so let's go through all the physiological factors once in short. Okay, so first is physiological factor which determines strength. The first one would be the size of the muscle. Bigger the size of the muscle, more is the strength. Second one is body weight, that is higher the body weight, more will be the strength. Third one is muscle composition. More the white twitch fibers, more is the strength because more is the contraction of the muscle. Therefore the strength also increases because of the because they contract faster. Okay, and they produce more strength. Intensity of nerve impulse, the stronger the nerve impulse from the nervous system, the stronger is the contraction, the more the strength. These are the four physiological factors for strength. Now let's come to speed. The first physiological factor of speed is the mobility of nervous system. That is, the more the nervous system is mobile, that is the faster it can inhibit and excite the motor centers, the faster contraction and relaxation of muscles happen. Therefore the speed also increases. Then second one is muscle composition. Again, white twitch fibers, the higher the white twitch fibers, more the speed. Then comes explosive strength. That is, explosive strength also depends on muscle composition, muscle size, as well as muscle coordination. Muscle size and muscle coordination can be developed. You can have bigger muscles, and also to a large extent they can be developed, but explosive strength depends genetically, that is, it depends upon the white fibers. So therefore it is different for different athletes. Now flexibility it also depends on flexibility. That is, more the flexible, more free the movement is, therefore higher will be the higher will be the speed. Last is biochemical reserve and metabolic power, that is ATP and CP for maximum amount of energy that is the muscles require for speed performances. That is, only the energy storage in the muscle is not enough, therefore you ATP and CP is required. If ATP CP is slow, then the muscle contractions will become slow and therefore the speed will decrease, therefore they are important. Now we come to the physiological factors which determine endurance. Okay, we are done with speed and strength. Endurance, and that is, the first one is aerobic capacity. Aerobic capacity is when an organism has continued a supply of oxygen to the muscles um, to continue for energy liberation in an endurance performance. We call that aerobic capacity. Aerobic capacity depends on oxygen intake, that is the amount of oxygen taken by our lungs from the atmosphere. Oxygen transport, that is how the oxygen from our lungs is taken from blood, and the percentage of hemoglobin is genetically determined, but the hemoglobin takes it to the muscles. Then oxygen uptake, how our muscles absorb and consume by the working muscles. The oxygen is consumed and absorbed by our working muscle, that is called as oxygen uptake. It also depends on the speed of the blood flow, temperature and partial pressure of oxygen. Then energy reserves, that is aerobic capacity, also depends upon the fuel upon availability of fuel to the muscles, that is for which energy for the activity is derived. Therefore it depends upon the muscle glycogen and sugar level. If muscle glycogen is less than and liver glycogen is less than a certain level, then fatigue occurs. So this was the aerobic capacity is the first physiological factor to determine endurance. What are the rest four factors? Rest three factors, that is lactic acid tolerance. If you control the the ability to tolerate higher concentration of lactic acid, also is a significant factor. Okay, so we know that the moment we start running, lactic acid develops in our muscles, and then we get muscle sprain or something because of anaerobic respiration which occurs in our muscles. So the higher concentration of lactic acid we can endure, the more will be, of course, our endurance. Okay, through improved training for more than 40 seconds or more, we can endure it. Okay, it can help in improving endurance performance. Then comes movement economy. Economical movements are significant for endurance performance. So basically the first one was aerobic capacity, which included oxygen intake, transport, uptake and energy reserve. Then comes lactic acid toleration. Then the third one is movement economy. The economical movements are significant for endurance performance. Runner who can run at a given pace with less energy expenditure can continue with the same speed for long duration. Good technique in endurance can save energy. So basically in endurance we know that marathons and all, we need a lot of stamina. So therefore movement economy also takes place. If you have a special technique through which you can maintain the same speed throughout for 3-4 kilometers, and then in the last kilometer you can increase your speed and agility and therefore win the marathon, then that's called as movement economy. Okay, that is, you have the special technique. Muscle composition, again there are two types of fibers. Over here in endurance opposite happens, since in endurance for longer duration we are running, therefore the slow twitch fibers which take longer time, okay, for contraction and relaxation, they are used most in most, whereas and all the marathon runners almost have 90% of slow twitch fibers in them. Now physiological factors determining flexibility. Okay, flexibility depends on number of factors. That is, the range of movement possible at a joint is called as flexibility. Now muscle strength, what is then muscle strength, that is, the higher the maximum the muscle strength, the maximum you can the maximum you can go against gravity and external force. Okay, so weak muscles become a limiting factor for achieving higher range of movement. For higher range of movement you need to have higher muscle strength. Therefore the first physiological factor is muscle strength. Okay, above was lactic acid, movement economy and muscle composition. All right, so then comes joint structure. There are various types of joints in human body. Some of the joints intrinsically have a greater range of motion than others. Then comes age and gender. We know that flexibility decreases as we age, but through proper training, it can we can sustain it. Stretchability of muscles, that is, the more the muscles are stretched, they contract, more will be the flexibility. Then internal environment, that is 10 minutes in a warm bath increases body temperature and increases flexibility, whereas 10 minutes staying outside in 10 degrees Celsius reduces body temperature, reduces flexibility. Previous injury, when there is a previous injury of a connective tissue, in case of flexibility, then the repair of it repair of it causes fibrosing on the affected area. Therefore, fibrous tissue is formed in the place of connective tissue. Now, effects of exercising on cardiorespiratory system. Okay, after doing exercise, what happens to our cardiorespiratory system? The increase in size of heart. When we perform regular exercise, muscles of the heart increase in size and strength. Left ventricle adapts to the greatest extent. Heart wallows, grows stronger and thicker. Okay, so therefore, if we do continuous regular exercise, okay, then our cardiovascular respiratory system, then there is an increase in size of heart. There is a decrease in resting heart rate. Heart rate exercise, regular exercises decrease the resting heart rate. If a 10-week training program is given to an individual, then whose initial resting heart was 72 beats per month, after this training time, his resting heart rate may be reduced to 10 beats per minute. After regular exercise, the heart finally becomes more efficient. It does not require to beat so quickly to supply blood to the body at rest. Okay, highly conditioned athletes have their resting heart rate in the 30s. Stroke volume increases at rest. Regular exercise helps in increasing the stroke volume at rest. Stroke volume at rest remains 50 to 70 in untrained individuals, 70 to 90 in trained individuals, and 90 to 110 in best endurance athletes. Okay, now increase in cardiac output tends to increase the cardiac output 14 to 20 liters per minute and 25 to 35 liters per minute in trained individual. Cardiac output can be as high as 40 liters per minute for best athletes. Increased blood flow in response to the need to supply the muscles with more oxygen during exercise. The body increases its number of capillaries. Existing capillaries also open wider. The blood redistribution becomes more efficient. Increase in maximum oxygen uptake. You can take more VO2, that is maximum need a constant supply of oxygen. Maximum oxygen uptake is VO2 max. Regular exercise increases VO2 max. So what are the effects? Basically, increase in the size of the heart, that is the muscles, they grow stronger, they become bigger after training. Decrease in resting rate of the heart. Stroke volume increases at rest. Increased cardiac output, more increased blood flow, increases the increased cardiac output, increase the maximum oxygen uptake or VO2. Okay, then comes effects of exercise on muscular system. That is, if you exercise regularly, what will happen to your muscles? We saw what will happen to your cardiovascular respiratory system. Now we'll see what happens to your muscles. Change in the shape and size of muscles. If you exercise regularly, then the size of the muscles will increase. They become enlarged. Then formation of more capillaries. The color of muscles is changed because new capillaries are formed. Muscle remains in tone position. Under some degree of contraction, it remains in tone position. Controls extra fat. Regular exercise controls extra fat in the body, burns extra calories. Change in connective tissue. Okay, efficiency in movement of the muscles. More movement is more efficient and smooth. Delays fatigue. That is, fatigue is delayed.